Dear students, my name is Rao. I am lecturer in chemistry. Today in this class, we have to learn about Graham's gas expansion law, which is very important in JEE mains or advanced or NEET exams. So already in previous videos, already I explained about what is the difference between diffusion and effusion. Already I said to you that diffusion is a continued process while effusion is a end process. So first we know that diffusion. So gases move from one place to another place spontaneously. This is known as diffusion. So in the similarly, we know that diffusion. What is diffusion? That means gases move from one place to another place. Gases move from one place to another place spontaneously. Gases move from one place to another place spontaneously. This is known as diffusion. So in previous video నేను ఆల్రెడీ డిఫ్యూజన్ అని చెప్పాను. గ్యాసెస్ ఒక చోట నుండి మరో చోటుకి స్పాంటేనియస్ గా మూవ్ అవుతాయి, దాన్ని డిఫ్యూజన్ అన్నాం. సో ఇన్ ద సేమ్ వే రేట్ ఆఫ్ డిఫ్యూజన్ represented by R. What is rate of diffusion? Simply say the speed of a gas. We know that diffusion means gases move from one place to another place spontaneously. That is known as diffusion. Gases ఒక చోట నుండి మరొక చోటికి ఒక స్పీడ్తో మూవ్ అవుతాయి, దాన్ని డిఫ్యూజన్ అన్నాం. అయితే ఎంత స్పీడ్తో మూవ్ అయితే తెలియజేసి దాన్ని ఏమంటామంటే రేట్ ఆఫ్ డిఫ్యూజన్. వాట్ ఈజ్ రేట్ ఆఫ్ డిఫ్యూజన్? Gases move from one place to another place with certain speed. That is known as rate of diffusion. That means gases move from one place to another place. Gases move from one place to another place spontaneously. This phenomenon is known as diffusion. But gases move from one place to another place with certain speed or velocity. It is known as rate of diffusion. What is rate of diffusion? Gases move from one place to another place spontaneously with certain speed or velocity. It is known as rate of diffusion. It depends on, it is represented by small r. So rate of diffusion R mainly depends on some factors. Generally, the factor R mainly depends on 5 factors. The first one is molar mass of the gas. Molar mass of the gas, it is represented by molecular. That means molecular weight of gas. Second one is density of the gas. Density of the gas, it is represented by small d. Third one is vapor density of the gas. Vapor density of the gas is represented by Vd. Fourth one is volume of the gas. Volume of the gas represented by. Fifth one is time taken for diffusion. Time taken for diffusion. That means small t. So the rate of diffusion R mainly depends on some factors. The important factors are 5. First, R depends on molar mass of the gas. It is also known as molecular weight of the gas, M. Second one, density of the gas, small d. Third one, vapor density of the gas, Vd. Fourth one, volume of the gas, Vd. Last and fifth, time taken for the diffusion, small d. So ఇక్కడ R అనేది ఫ్యాక్టర్ డిపెండ్ అవుతుంది. ఫస్ట్ మోలార్ మాస్ ఆఫ్ ది గ్యాస్ యొక్క మాలిక్యూల్ గ్యాస్ యొక్క డెన్సిటీ సాంద్రత మీద, వాయువు యొక్క బాష్ప సాంద్రత మీద, తర్వాత వాయువు యొక్క ఘన పరిమాణం, లాస్ట్ వన్ ఏంటంటే డిఫ్యూజన్కి పట్టిన సమయం టీ మీద డిపెండ్ అవుతుంది. సో ఆర్ డిపెండ్స్ ఆన్ 5 factors. Relation between R and these five factors were generally proposed by Thomas Graham. So who is Thomas Graham? Thomas Graham is the scientist who made experiments on the gas diffusion and gas expansion, and finally he discovered a law which is known as Graham gas expansion law. So Thomas Graham, what he meant, that means the relation between R and these five factors. Thomas Graham R కి ఈ ఫైవ్ ఫ్యాక్టర్స్ మధ్య ఉన్న రిలేషన్ ఎలా ఫైండ్ అవుట్ చేశాడు. సో ఫస్ట్ యూ నోట్ ఇట్. సో Graham's first law. Graham's first law. So according to Graham's first law, the rate of diffusion R is inversely proportional to the square root of its molecular mass. Next repeat, another repeated. The rate of diffusion R is inversely proportional to the square root of its molecular mass. That means it is mathematically represented as R proportional to square root of 1 by m. That means R, rate of diffusion R, is inversely proportional to 1 by m. Inversely proportional to the square root of its m means molecular mass. Here R is equal to rate of diffusion. Here where R is equal to rate of diffusion, and m is equal to molecular mass of the gas or molecular weight of the gas. That means when R increases, rate of diffusion increases, then m increases. When R decreases, m increases. So according to first law ఏంటంటే rate of diffusion R అనేది m molecular inversely proportional, square root inversely proportional. Here R is equal to rate of diffusion, వ్యాపన నియమం is equal to molecular mass of the gas. So it is written as therefore R1 by R is equal to root of by m2 by m1. So here the formula is generally given for many NEET exams, where R1 is equal to diffusion rate of gas, diffusion rate of first gas, and m1 is equal to molecular mass of first gas or molecular weight of first gas, and R2 is equal to diffusion rate of second gas, and m2 is equal to molecular mass of second gas. So R is equal to where R diffusion rate of first gas, that means speed rate and expansion rate of the first gas. One is equal to molecular mass of the first gas. R2 is equal to diffusion rate of second gas. M is equal to molecular mass of the first gas. So generally problems like JEE mains or NEET or any generally gives on this formula. So R1 by R2 is equal to square root of. For example, a bit on this formula. For example, a gas cylinder contains it has a separate layer. A gas cylinder separate layers. A gas cylinder it contains layers. The first layer it contains O2 gas. Second contains N2. Third one is methane. One is SO2 gas. If a small hole takes place on the cylinder, దీని మీద if a small take if a small hole takes place on the cylinder, which gas moves fast, which gas moves. So problem is a cylinder which contains layers is a mixture of gases. The first gas is oxygen, second one nitrogen, third one methane, fourth one is SO2. If a small hole takes place, which gas moves fast? Moves fast. Which gas moves fast? Which gas move? Which gas moves? So, according to on applying this formula, సో ఒక సిలిండర్ లో లేయర్స్ ఉన్నాయి, అరలర్లుగా ఉన్నాయి. ఫస్ట్ లో ఆక్సిజన్, సెకండ్ లేయర్ N2 ఉంది, థర్డ్ లో CH4 మీథేన్ ఉంది, నాలుగు నాలుగు SO4 ఉంది. చిన్న రంధ్రం పెడితే ఈ గ్యాస్ ముందు బయటకు వస్తుంది, ఏ గ్యాస్ స్లోగా వస్తుంది. మన రన్నింగ్ రేస్ ఉన్నారనుకోండి, వెయిట్ ఎక్కువ ఉన్న వాళ్ళు స్లోగా పరిగెత్తారు, వెయిట్ లేని వాళ్ళు స్పీడ్గా పరిగెత్తారు. అట్లా మాలిక్యులర్ వెయిట్. సో the relation are proportional to square root of 1 m. Therefore, oxygen molecular weight 32 grams, N2 nitrogen is 28 grams, methane CH4 is 16 gram per mole, SO2 sulfur dioxide is 64 gram per mole. So among these four gases, the lightest gas is methane. Methane fast. Methane. The first alkane, it has two names, Mars gas and fire damp. దీనిలో మాలిక్యులర్ వెయిట్ తక్కువ కాబట్టి కంటే ముందు స్ప్రెడ్ అవుతుంది. తర్వాత సల్ఫర్ డైఆక్సైడ్ SO2, మాలిక్యులర్ వెయిట్ ఎంత? సల్ఫర్ డైఆక్సైడ్ మాలిక్యులర్ 64 ఉంది, ఎక్కువ ఉంది కాబట్టి స్లోగా మూవ్ అవుతుంది. సో ద ఆన్సర్ ఈస్ methane is first. Methane moves fast, first one, and the slowest move gas is sulfur dioxide because it has weight is 64. Methane moves fast because it has lowest. So on applying this formula, upper square root of 1 by m. ఈ gases లో మీథేన్ లో వెయిట్ తక్కువగా తొందరగా స్ప్రెడ్ అవుతుంది, సల్ఫర్ డైఆక్సైడ్ ఎక్కువ ఉంది కాబట్టి స్లోగా మూవ్ అవుతుంది. సో దిస్ Graham's R proportional to root of 1 by m, or R1 bar 2 is equal to square root of m2 by m. That implies R1 by R is equal to square root of m2 by. Next, Graham's second law. Graham's second law. Next, Graham's third law. So what is Graham's second law? That means the rate of diffusion R is like molecular mass. The rate of diffusion R is inversely proportional to the square root of its density. Definition repeated. So the rate of diffusion R is inversely proportional to the square root of its density. ఈ యొక్క R అనేది వ్యాపన రేట్ R అనేది దాని యొక్క సాంద్రతకు వర్గానికి విలోమానుపాతంలో ఉంటుంది. It is mathematically written as R proportional to square root of 1 by D. R proportional to square root of 1 by D. That means when density decreases, R increases. So then ఏంటంటే density R increases. When R decreases, density increases. So that implies it is also represented as R1 by R2 is equal to square root of D2 by D1, where where R1 R2 is equal to square root of D2 D1. This is the second formula. Second one. The first one is R1 by R2 is equal. This is the first formula. R1 by R2 is equal to square root of M2 by M. So this is the second one. R1 by R2 is equal to square root of D2 by D1. Second one. So where R1 is equal rate of diffusion of the first gas, R is equal to rate of diffusion of second gas. D1 is density of first gas. D2 is equal to density of second gas. So next one. Same. The rate of diffusion R like density. The rate of diffusion R is inversely proportional to the square root of its vapor density. So the rate of diffusion R is inversely proportional to the square root of its vapor density. It is represented as R proportional square root of 1 by VD. సో ఇక్కడ వేపన రేటు అనేది దానికి వేపన్ రేటు ఆర్ అనేది ఆ వాయువు యొక్క బాష్ప సాంద్రత యొక్క వర్గానికి విలోమానుపాతంలో ఉంటుంది. ఒక వాయువు యొక్క వేపన రేట్ అనేది ఆ వాయువు యొక్క బాష్ప సాంద్రత యొక్క వర్గమూలానికి విలోమానుపాతంలో ఉంటుంది. That means when R increases, then vapor density decreases. When R decreases, vapor density increases. So it is also known as R1 by R2 is equal to square root of VD2 by VD1. So this equation is 3. This equation is 3. First equation R1 by R2 is equal to square root of M2 by M1. Second equation, this second one. This is third one. Here VD1 is equal to vapor density of first gas. VD2 is equal to vapor density of the second gas. So right. Next, Graham's fourth law. Next, Graham's fifth law. So next, the fourth factor is volume. So what is the relation between R and volume? So according to Graham, the rate of diffusion R is directly proportional to the volume of the gas. So definition repeated. The rate of diffusion R is directly proportional to the volume of the gas. So it is mathematically written as R proportional to V. V is equal rate of diffusion, V is equal to volume of the gas. So it is mathematically represented as R1 by R2 is equal to V1 by V2. So this is fourth one. So ఇక్కడ వేపంలో R అనేది ఆ వాయువు యొక్క ఘన పరిమాణానికి అనులోమానుపాతంలో ఉంటుంది. When R increases, when volume of gas also increases. When volume of gas increases, then R also increases. When V decreases, then R also decreases. వాయువు యొక్క ఘన పరిమాణం పెరిగితే R పెరుగుతుంది, V తగ్గితే R. Where R1 by R2. So we know that R1 is equal to diffusion rate of the first gas, R2 is equal to diffusion rate of second gas. V1 is equal to volume of first gas, V2 is equal to volume of second gas. The next one, last topic is Graham's fifth law. So what is the relation between R and T? So Graham's fifth law, the rate of diffusion R is inversely proportional to the time taken for diffusion. So definition repeated. The diffusion rate of R is inversely proportional to the time taken for the diffusion. So it is mathematically written as R proportional to 1 by T. So rate of diffusion R అనేది దానికి పట్టిన టైం Tకి ఇన్వర్స్లీ. That means when T increases, rate of diffusion decreases. When T decreases, R increases. వేపర్ రేట్ R అనేది ఆ పట్టిన టైం విలోమానుపాతంలో ఉంటుంది. సో ఇట్ ఈస్ మ్యాథ్ written as that implies R1 by R2 is equal to 2 by T1. This is fifth law. So till we have to write about five formulas. So these five laws are known as Graham's gas expansion laws. So on conclude on by that means by these five. So on applying these five formulas, we can simply written as Graham's gas expansion law. First you write it. So now we have to explain about five Graham's laws. So the first law is R1 by R2 is equal to square root of M2 by M1. This is first law. This is first law. Next second law is Graham's second law. R1 by R2 is equal to square root of D2 by D1. This is second. And third law is R1 by R2 is equal to square root of VD2 by VD1. This is third law. Our fourth law is R1 by R2 is equal to V1 by V2. This is fourth law. Last one is fifth law is R1 by R2 is equal to T2 by T1. This is fifth law. So the first law R1 by R2 is equal to square root of M2 by M1. So where R1 is equal to the rate of first gas, R2 is equal to rate of second gas, M1 is equal to molecular weight of first gas, M2 is equal to mass of second gas. So here D1 is density of first gas, it is equal to density of second gas, and V1 is equal to vapor density of the first gas, VD2 is equal to vapor density of second gas. V1 is equal to volume of first gas, V2 is equal to volume of second gas. T1 is equal to time taken for first gas, T2 is equal to time taken for diffusion of second gas. So simply so from there are five equations from 1, 2, 3, 4 and 5 equations. So the five equations we can simply write as R1 by R2 is equal to square root of M2 by M1 square root of D2 by D1 square root of VD2 by VD1, that is V1 by V2 is equal to V2 by V1. So this is Graham's law, complete law R1. What is complete form of gas? That means Graham's law R1 by R2 is equal to square root of M2 by M1 is equal to square root of D2 by D1 is equal to square root of VD2 by VD1 is equal to V1 by V2 is equal to T2 by 1, where R1 is equal to diffusion rate of first gas, R2 is equal to diffusion rate of second gas, M1 is equal to molecular mass or molar mass of the first gas, M2 is equal to molar mass of the second gas, D1 is equal to density of first gas, D2 is equal to density of second gas, VD1 is equal to vapor density of first gas, VD2 is equal to vapor density of second gas, D1 is equal to volume of first gas, V2 is equal to volume of second gas, T1 is equal to time taken. That means time taken for diffusion of first gas. T2 is equal to time taken for diffusion of second. So, what is the complete form of the Graham's law? R1 by R2 is equal to square root of M2 by M1 is equal to square root of D2 by D1 is equal to square root of VD2 by VD1 is equal to V1 by V2 is equal to T2 by T1. So, this is very useful for competitive exam, JEE mains or advanced and NEET. Generally, if you take any competitive exams like JEE mains or one or two bits must be on Graham's law. So this topic general belongs to gaseous state. In states of matter, one part is the state. So the important topic is Graham's gas law. So what is the Graham's form? R1 is the form. So Graham's law యొక్క complete గ్రాహం వాయు వ్యాపనం యొక్క కంప్లీట్ మొత్తం రూట్ అంటే 1 by R2 is equal to square root of M2 by M1 is equal to square root of D2 by D1 is equal to square root of VD2 by VD1 is equal to V1 by V2 is equal to T2 by T1. R1 మొదటి వాయువు యొక్క వ్యాపన రేటు, R2 రెండవ వాయువు యొక్క వ్యాపన రేటు, M1 is equal మొదటి వాయువు యొక్క అనువేగము, మొదటి వాయువు యొక్క అనుభారం, రెండవ వాయువు యొక్క అనుభారం, మొదటి వాయువు యొక్క సాంద్రత D2 రెండవ వాయువు యొక్క సాంద్రత, VD1 మొదటి వాయువు బాష్ప సాంద్రత, VD2 రెండవ వాయువు యొక్క బాష్ప సాంద్రత, V1 మొదటి వాయువు ఘనపరిమాణం, V2 రెండవ వాయువు ఘనపరిమాణం, T1 మొదటి వాయువు యొక్క దట్ మీన్స్ మొదటి వాయువు యొక్క వ్యాపన రేట్ కాలం, రెండవ వాయువు యొక్క వ్యాపన రేట్. So this formula we have there are many 25 formulas. For example, R1 relation between rate of the M2. This is R is equal square root of. So what is the relation between? This is the relation. Molar direct. Relation between density and VT. Relation between molar mass and VT. So what is the relation between molar mass and vapor? That means volume. That means V1 by V2 is equal to square root of M2 by M1. This is another formula. In the same way, what is the relation between density and time? Square root of D2 by D1 is equal to T2 by T1. Square root of D2 by D1 is equal to T2 by T1. This is another formula. So in this way, you have to write many formulas. There are generally 10 to 14 formulas. 10 formulas or 8 to 10 formulas or more than 10 formulas. You can generate this formula. Okay. So this is the 5 formulas. Remaining 5 to 6 generator formulas. So this is the Graham's law. Thank you. Please, please subscribe my channel and please do not forget to press the bell icon. Thank you. In next class, we meet in problems on Graham's law. After writing this, please practice this formula for good recitation and good marks. We meet